This is Chapter 8, Part 10. This is the last video in Chapter 8, and in this video we're going to cover carbocation rearrangements in multi-step mechanisms. Specifically, the example that we're going to look at here is an SN1. So if you're looking at this SN1 reaction, hopefully something jumps out at you as being funny. Notice that the leaving group over here is gone, right? But instead of going in and adding where the leaving group was, the water added in a different position as an alcohol. So what's going on here? So if you look at the mechanism, what's happening first is the leaving group falls off. This is a heterolytic cleavage. Next, you can see that what we have is a hydride shift. Okay, so remember that in the hydride shift, the hydrogen and then all of its electrons, so this is two electrons or one pair, is moving over here to the carbocation. And if you guys remember why this is occurring, this is because we're going from a secondary carbocation to a more stable tertiary carbocation. So this is your carbocation rearrangement here that's occurring. Once the more stable tertiary carbocation is formed, the water can coordinate. And then of course, this is going to end up with a positive charge on the oxygen, which will be quickly deprotonated in a proton transfer reaction. Another water in the solution. You'll notice that there are two equivalents of water that are required. One that comes in, and then one that's going to do the deprotonation or the proton transfer to get to the final alcohol product. So now we can see whenever you have a potentially a less stable carbocation, so think primary or secondary, right? Because a primary can go to a more stable secondary carbocation, and a secondary can go to form a more stable tertiary carbocation. So whenever either of those carbocations are formed, you have to consider the possibility that you might have a carbocation rearrangement. So it could happen in the form of a hydride shift, as shown here. The other possibility, of course, is a 1,2 methyl shift. So if this hydrogen here, or hydride, was a CH3, you could also have that shift, remember? So in the case of the SN1, you have the leaving group falling off, right? Then the hydride shift, formation of the more stable carbocation, and then coordination. In this case, we have a water coming in, so there's also a proton transfer, but in some examples of these, you might be done after the coordination step. Okay, so that is it for this chapter. Here is the study guide for the chapter. Make sure to review all of the points in the study guide and contact me if you have any questions about any of these points.